hopefully that gives you a sense of the kind of systems that people want to build, right? And these are a lot more complex than the. So they all use MPEG-4, MPEG-2, whatever you looked at for different components, but we're trying to see how we can merge all of them into a multimedia experience, right? So for today's class, I would like to continue and finish up the synchronization and then go on to group communication. So do you have any questions so far about what we have been able to accomplish? We'll have the midterms on Thursday, and like I said, it'll be open book, open notes, and so if you have any questions about that or anything else, let me know here.
Do you have the format of the test or not yet?
No, not yet.
Okay.
It'll be like your homework assignment. I haven't made it yet, right? It won't be like your OS exam where there's multi choice and stuff because some of you were in the class, right? So it'll be similar to the operating systems class, in the graduate operating system class. Whoever took it with me, I guess only you took it. Okay, you took it. It won't be like the OS class that you guys took, or some of you took. So this is more of a grad level class. So I'm not trying to find out if you have all the because we went through it at such 35,000 feet view of multimedia systems kind of stuff. So does that help kind of set, right? So far we're trying to look at the different ways of synchronization specification. That's where we left off in the last class. Unfortunately, I made a. So we left off in this slide, right, which essentially talked about different ways of providing the specification for something like what you saw on the YouTube site. So one of the ways is the interval-based specification, which can say what happens after, what happens before, specifications based on time intervals, right? So, and even that gets pretty complicated depending on the different kinds of animations you look at. So for example, if you only specify one delay parameter, right, it can mean that before, after, but before can mean before some animation ends, you do something. Before can mean purely one event happens before the other, or because these are two overlapping events, right? So we are talking about. So if you have one multimedia event and you have another event, right? So that may involve. So this is one way of specifying before. So if you have this as a reference, the other one can be entirely within the reference time frames. If you think of this as the time, right? With respect to this one, the other object can start afterwards, can be fully within the stuff, can be entirely before this, can be, right? So the different ways of saying that is, this is one of the reference objects they're looking at. The other one would have finished before that finishes, would have been entirely within the other object, would have started after this started, right? Could have been over here. So there are different time ways that you can specify these things. And each one of them, like for example on the little round thing, right? You would say before that finishes, then some other event happens. So the interval specifications, even though it sounds simple when you talk about before, after, can get fairly complicated because you have to specify, because you have two time ranges. You have the start and then you have the end, and you have the other streams start and the end, and that defines where they overlap, right? And when you talk about two delay parameters, you can specify when they start and they end. Three delay parameters. Essentially, you're trying to say where this D1, D2 D3 and D4, what the relationships are, right? And this doesn't even include the notion of the skew parameter, where one of them can start potentially later than the other one because you can't really see them, the audio and video and stuff like that. So essentially that says that there is a zone around these things where you can't really see the difference, right? So if you add those, add these two here, the specification becomes fairly complex. So now you have one event starting, one event ending, another event starting, another event ending, and there's also the notion of some of these things you can't really see, so you can have this fuzzy stuff. So that's the specification for one of two objects. And imagine you have lots of objects, like the YouTube example you saw. There's this little circle thing, then there's these two advertisements, then there's things happening on the top, the share, our favorite kind of thing. So once this circle thing finishes, then it changes something else at a different location. All of them have to be explained. All of them have to be specified. So your specification can get fairly complicated. And I don't know why this thing is going to sleep so often. So another way of specifying that, instead of having to do with this interval thing, because interval things can get very complicated, is to have a reference time frame and then say when things start, right? So rather than saying how these things are related, have a virtual time frame which says that you specify D1, D2, D3, and D4, and go from there. And the time frame can be absolute or relative, because I guess the music notes are relative, right? I have no music background, so I don't know how you read those music notes. How many of you have music background too? What does it mean? Like when you see the book talks about the symbols and it says it's relative, right?
Oh.
What is it? How do you read this thing?
Well, you mean the length of the notes, basically?
What does this mean? I actually don't know what.
The lines represent what note it is.
The lines?
And the type of symbol that you draw is the length relative to the timing scheme that you have.
Okay. So
like a quarter note that lasts for 1 beat could last for 2 beats on a different timing scheme, but you'd write it the same.
okay. So that's one way of specifying this stuff, right? I'm not pretending I understand what all it meant, right? But that's one way of specifying this stuff, right? So if I paraphrase it, what you're saying is I can have the same connotation, but depending on the relative time scale, this particular stuff may mean longer or shorter. Right. Is that right? Yeah. Right. So you specify this thing, and depending on the relative scale, this could last for longer or shorter period of time, right? So that's one way of specifying what you want. So you specify the different sequences, and depending on the time scale, they change. And you can think of more control flow based, where it says once this finishes, something else starts. So you no longer have the time frames, you have relative positions. You say once that something finishes, something else starts. And you can have a hierarchy of these things, and you can so it can get fairly complex. So to define what that YouTube does, it's a fairly complex model, right? So if you click something changes. So that's an open-ended thing. There's no time frame on when you can click it, right? So when that happens, the events change, and then you have this little round thing which controls something else. So that's part of. So eventually you have to get these, So there are different ways, and there's also script-based, right? So where you can have some programmable events going off and creating these variable stuff. And one of the other example, if you didn't have the YouTube, is the DVD menus, right? So when you have the DVD, I think I'm running low on battery, right? So essentially, when you have DVD movies, you have the menu that you can click, and when you click the menu, you can go to different chapters or set some different audio parameters, and these are specifications of how DVDs should respond to those different events, right?
I have a quick question.
Yeah.
Time-specific Petri nets, what are those?
So Petri nets are based, so the Petri nets define the Markovian, so they define the time transitions on what happens when you go from state 1 to state 2, right? So they're defined by time. So time specific Petri nets can also include open-ended stuff like user interactions where there's no time model, right? So this one you can say at time t1 you go from state 1 to state 2, whereas here you would base on the events, right? So it's a augmented Petri net model. Let me see if I can. Okay, hopefully it should fix that. So those are the different ways of specifying these things. And the book talks about a number of different case studies on how we interact and create these specifications. I'm not going to go through the details of many of those. Some of the things that we probably looked at is the QuickTime and Windows Media, which defines some rudimentary notions of specifications, right? I think the demo on the YouTube is a lot more complicated system, but systems like these can produce really rich multimedia, right? And we're only beginning to see a few of these things out in the wild, but these research systems can specify a lot more complicated stuff. And we'll look at some of those systems when we start reading papers, right? Essentially that can tell you how many of these objects would have to synchronize at a fairly high level. So if you think of the symphony example, the specifications are a lot more complicated, right? So in summary, I mean, I hope you get a flavor of the complication we're talking about, right? So we have the different media streams that we looked at. It could be MPEG 2, MPEG 4, or what have you. But the real fun starts when you try to put these all together into a fashion where users get a good feel of how things should look like. I'm quite glad that YouTube is out there, because if I didn't have YouTube, I would be talking about this in a more abstract concept. But you can look at YouTube and see that it gives such a nice, I think it's a nice user interaction where it creates these video streams and then lets you interact with them and play the next stream or what have you. And ideally, we would like to build more complicated applications like that sort of stuff. And one of the things that Chris asked, why would you want to use Flash rather than MPEG 4 or whatever, right? So Flash can still use MPEG 4 for the different streams, and Flash does not define what the encoding or the compression stream. Flash is, I mean, we're talking about a different thing. We're talking about one which is just this stream, the other one which is more complicated, which defines the streams and the different synchronization primitives, right? So the last section that the book refers to, that we'll look from the textbook, is the notion of group communication. Group communications in terms of video chats or what have you. The book goes through a number of different techniques and a number of different ways that you specify what is going on, and I'll go through a fairly quick overview of those. We'll actually spend at least 3 lectures on actual systems, right? So one of the ways that you differentiate the group communication mechanisms is, first you have to define what a group is, what the groups are. The next notion is the notion of where the different groups are, or where the participants are. So the participants can all be in the same location, like what we have here, or could be in different location, right? The participants can all be at the same time simultaneously, or they could be on different time scales, right? So they could be either synchronous or asynchronous. They could be on the same location or different locations. So for example, if you have the same location and synchronous, right, you can think of this as this presentation. We're all in the same location. We're not interacting with it, right? But the idea, the application for that would be, if I give control for the mouse and moving this to all of people who have laptops here, right? So they should be able to interact with the screen, not just in terms of moving to the next screen or what have you, but also be able to change these contents, right?
That would be a mess.
So that's where we have the issue of, I think it's in the next slide, the issue of flow control, right? And as you can imagine, even for this system, right, if all of you started to act on this stream, you have to have the notion of flow control. And I'm kind of jumping ahead. And flow control, you do what you do in real life, right? In this case, I have control over the floor. So if some of you start to scribble something, then I can control it because I'm the coordinator. So I can say, don't do that, right? So I should be able to kick you off or what have you, because I'm the floor coordinator and I have some authority, right? And in the terms of the lecture, you can see how that's not that hard. I can kick you off the control system, but in the case of a more democratic system, that may not be so easy, right? So if you let all the students control something, right? Control this screen, right? You can either create beautiful art forms because all of you did the right thing, or you can have graffiti or nasty things. And so we don't really worry about what would happen out of it, but we have to worry about how this control happens, right? So for now, assume that that there's flow control, and so it may not be a bad thing. I mean, this is the notion of a whiteboard, right? And the systems have looked at that, and being able to control, being able to add stuff to the whiteboard in a small collaborative system, collaborative location, may not be a bad thing. I mean, as long as I trust that people are not doing something malicious, right? Same location, asynchronous stuff. So if you're doing synchronously, then we have to worry about how to do the flow control and all those things. But if you don't have to worry about it in the same context, so we're all here. You create something, you store something, then I look at it later, kind of stuff, right? Decision control, or I guess the PowerPoint workflow kind of thing. So they deal with a different set of issues. One user finishes the operation, then sends it up to the other one, and then they operate on the things. Different location synchronous is the notion of the video conferencing kinds of systems, right? Where you not only have to worry about the flow control issues, but you also have to worry about the network latency and how to make the systems work. Is this room kind of hot?
Yeah.
Okay. Can I open the... And the notion of a different location, asynchronous systems, or email, or news groups, right? And we don't usually talk too much about those systems because it's assumed that people are in different locations. So there's no real-time requirements on when you want the email to reach the other person and all those things. But you can imagine systems like that, like those. The other complication is to create the notion of static or dynamic set of users, right? Adding more users, the complication comes in when you have the notion of roles, right? Roles in terms of coordinators or participants. So when you add more users, you also have to have a notion of role change. So the notion of role change, the user change would be if I step out and somebody else walks in, right? And maybe they become the coordinator of the room. How do you change these roles? How do you make these things happen? It's a challenge, right? How many of you had a video conference using like Skype or Yahoo or one of those things, right? So you have done a conference, right? More than one users. So you probably have seen this notion of a coordinator and role change and all those things, right? So for example, I think Skype does not let you. So I chat. Whoever initiates the conversation is the coordinator, right? For life, right? They can add more users, they can kick off users, the other users have no control over being invited or thrown out. So they're completely passive. They can't just join unless the coordinator invites you, right? So if you get kicked off, you have to be re-invited to join the stuff. So the coordinator has absolute control, right? I'm not sure how the other systems work. Do you guys?
I think Skype, whoever initiates the conference call can add the people.
Mm-hmm.
But I mean, unless there's a problem, I think the user disconnects. I mean, I don't think you can actually like, boot them off once they're in the conference call.
Mm-hmm.
So that's kind of.
But can they just join? Can you see if there's a conference?
You
You're
have
gonna
to
invite
invite
them.
them.
You're gonna invite them.
You have to initiate a call to them.
But you is the coordinator, right? This.
Right, the first person is the
Okay.
And if the coordinator, for some reason, hangs up, the whole thing just falls apart.
Yeah.
Okay.
And here's a problem with the computer. Everyone's
Okay. And as you can imagine, that's acceptable for something which is pseudo free like Skype, but more richer kind of systems would need more complicated mechanisms for role change and being able to add and change new users, right? Another parameter to this whole system is the notion of how homogeneous the different users are or how heterogeneous you expect them to be, right? So if you expect all of them to be using Skype, I mean Skype is a pretty simple application if you look at only the audio component, right? But if you use the Skype with video, with whiteboard or something, so if one of the users join in on a cell phone, right, they may have different facilities in terms of video chat or audio chat, and how would you coordinate those? How would you have a group coordination where some users have some capabilities while others don't have, or research challenges that you would have to worry about, right? So the whole different set of ways that you can define the group and you can define how the groups collaborate, right? And so that's one of the reasons why I like the way that we kind of look at the textbook and then we can actually look at actual systems to see how it manifests for real applications that you can think of. So the control here is the notion of the flow control or kind of stuff, right? So it could either be centralized or distributed. Centralized solves a lot of problems because I have absolute control over who gets to say something on the board, right? So, and we kind of use that in this classroom too. So when I'm talking, hopefully not all of you talk, right? If one of you asks something, I kind of yield the floor to you and then get it back from what you did. And that's actually a good model of how things work, right? So if you go to a conference room, people usually don't start talking when they feel like. People kind of look around for cues to when it starts, right? It seems so natural that we don't actually think about it, but when you build these things, you have to worry about those, right? So there are two ways that conferences are real like conferences work, right? One where there's somebody in the front who says, okay, now you go, and they say, now you go, whatever, right? And those, I guess, are not conferences. Those are more like a lecture kind of systems, right? But in other cases, you kind of look around to see what happens, right? I mean, if you have something to say, you don't just start to say it. You kind of enter into the conversation in a socially acceptable fashion, right? Thinking back when you have a bunch of people talking to each other, you don't all wait for everybody to go quiet before you talk, right? If you do, then you may not be able to join in the conversation at all. So you kind of ease in your way. You kind of look for good points to enter, right? When you want to do the same thing for a video chat or one of these group communication systems, you have to have those visual cues because otherwise it's very unnatural, right? So in the case of like in this room, right? So if one of you wants to talk, how do you initiate a response? One of the ways is when I go quiet, right? When I say, I'm asking who of you wants to take control, right? I'm saying, can you think of a way that you would initiate a conversation, initiate a session? Yeah.
Are you asking how we know when we can talk, or how we know we would want to talk?
How do you know when you can talk?
When you stop talking.
That's one way, right? If I don't stop talking, how do you do that? If I'm can you talk?
If you're polite, you raise your hand.
Yeah.
Or you could wait for the middle of a sentence where you pause. If you do pause.
So all the social cues, if I don't bring it to a system that collaborates using cyber systems, it's very annoying. So if any of you had talked on a conference call system, right? How many of you have done a telephone conference call with more than 2 or 3, right? What is the experience? Like how do you feel the system to be? What is the single most thing which annoys you? What is the single thing that doesn't?
More than one people talking at the same time.
And can you guess like why it's such a?
Oh, okay. I mean, more people, like, we were in an office and two people at our location were trying to talk to the people at the other location. They both had answered the same question, so they both had an idea, and one was kind of talking, trying to answer the question simultaneously.
But what would you like to have to make that work? What's the?
If you wanted to implement it in a system rather than rely on people socially, then you just make it to where if somebody's talking, nobody else can talk, or it shuts off all the
See, so one of the ways that they deal with this stuff is like when somebody has a flow control, it shuts off everybody else, right?
Then they could just talk for hours on end.
Exactly, right? I mean, that's a horrible system I found because you can't interrupt this person, right? Worse still, it's not like the person who has control wants to keep control, right? I mean, there are two kind of people. One who just likes to talk and they don't want anybody else to interrupt. And this is excellent, right? If I'm a politician, I don't want to hear any questions, then I want to take control like that, right? There may be other conditions where I don't want to keep control, right? So I would like for somebody else to, so if I ask like, so do you guys have any thoughts, right? At that point, if I don't see any response at all, I would want to continue. And I don't get that feedback, right? And that's a very complicated, that's very hard because I need to get these cues on how, when people want to get into the conversation, right? So one of the things, like so I wish you were able to see from here. One of the things I noticed is some of you kind of like raise their hand, like, a little bit, right? So I can kind of look to see that you want to communicate, right? And then you kind of go back and say, no, I don't want to participate or something. So I can see this stuff. So if I don't get this, when I don't get this cues and all I hear is a noise, right? You frequently see that there's silence when no one is sure who has to go, and then you hear when everybody jumps in, and then they all have to back off, right? And solutions like silencing others and all have their issues. So what you really want is some way to not only capture what is being said, but also the other stuff, right? One of the systems that came out of Park and all was how to show users when somebody is trying to initiate a conversation, right? So, for example, if you think of you walking by somebody's office, right, and you want to talk to them, can you imagine how you get their attention? So, assume that this is my office, and you want to get in, right?
Knock on the door.
That's one way, right? That's fairly intrusive, right? So if suppose you see I'm sleeping inside, you probably knock on the door. That's acceptable, right? But suppose you see I'm talking to somebody else, right? What are the different ways you initiate this stuff?
Wave or leave a message on the door.
Wait till they're done. Wait till you're done talking. Physically remove the other person so you can start talking to them.
The other thing you do is you kind of walk by the stuff, right? So you know that I can see you, so you kind of go back and forth.
It's good to keep going back.
I hope you guys have done that, right? I mean, it's where you're not doing anything. You're not. I can't hear you because you're outside, but I can see you, right? Not necessarily because you come in and like you wave at me, but I can see you in the back of my eyes that you're walking, right? And those are very important because those give some social clues, right? So if you knock on the door, then I assume that you have something important to say. You don't knock on the door to say hi, right? Because if you're in the middle of a conversation, you kind of do the stuff, right? But otherwise you kind of walk around, right? And you kind of try to get attention. Any system which you want to do, if it can't give you that level of the subtlety in what happens, right? So there are research projects which try to show how to prompt when somebody is trying to do a chat, right? And it sounds trivial, but it's not. So if somebody wants to do a video chat or audio chat with me right this moment, right, my computer seems like it's online. So how it responds back to me to get my attention, right, depending on how important that is. So if there's something that somebody needs to get hold of me, which is more important than this class, it needs to be in some fashion to let me know, right? All this the annoying beep beep things, which the flashing things, they don't really care about what I'm doing, what the context and all those things. And those are extremely hard. We haven't even scratched the surface of any of those. I mean, right now, all you hear is this beep beep and all those things, but you want these systems to evolve into something which is more
Have you
useful.
ever used Live Meeting? Microsoft Live Meeting?
No? Oh,
It's the net
The one-
meeting on steroids version.
Okay.
Well, a net meeting.
Okay.
And I used it over the summer, and it's pretty neat because it allows, like, you got people to log on, and then you're sitting around the table. They actually have a little drawing of a table. You got people sitting around, and each of them has a name on top. You have a question, you click, and you turn your color from green to red. And whoever is giving the lecture can just stop and say, "Oh, you have the red thing.
Okay.
Talk." And that's kind of the way you interact, which is pretty neat. And in other ways, it's just you can also transfer the power to somebody else within the audience as a presenter, so somebody else can start presenting on top of you.
And yes, and we'll see some of the systems which try to be a lot more smarter than that, right? A lot more smarter than having to interact with it through a computer system, but rather trying to figure out what you're doing by looking where you're looking and stuff. One of the HP system we look at will have like lots of cameras around you to give the feel of more of what happens, right? Rather than just prompting, right? So it's supposed to be able to see where you're looking to see what kind of systems, how you want to interact, right? Those are excellent stuff, and that. So if any of you use the conference systems, you know how bad things are, and you know where it has to go, and where it has to go involves all these inputs. So the cooperation model in terms of what we want to do, the book separates it out into the transparent model and where you're aware of what happens. In the transparent model, you have no idea that there's collaboration happening, right? So you can take your existing system, you can take like your PowerPoint and somehow make it collaboration oriented, where people can make changes at the same document at the same time, right? And depending on how seamless the application is, you may or may not notice what is happening, right? So if you're doing a source code edit, I would not want it to be transparent, because I don't want to be changing something and somebody is changing without me being aware of what the changes are. In terms of the cooperation, you can have cooperation where the primary aim is the cooperation, right, with the computer. So it either emphasizes the collaboration or it emphasizes the computing component of it, right? And in both these systems, you are aware that there is collaboration. You're aware that there's stuff going on, and it depends on how you feel about it, right? So if you have to explicitly state that you want to talk by clicking on some mouse and everything, you are more aware of the collaboration component, right? If you want a system where things seem to flow kind of naturally, that's another form of collaboration, right? And on all these systems, you are aware that there's collaboration going on. Whereas in the first model, you're not aware of what's happening. You just you do your work, and people can collaborate on the side. And you see more of these things either in terms of like video games or chat and other applications for normal users, right? So then you want to define a notion of a collaboration architecture. So now you want to figure out what makes the system that will make this group communication cooperations possible. So the three different main components of this architecture is first the rendezvous component, right? The rendezvous component figures out it defines how the different group members congregate, how the different members add or add each other either. So the first thing is, how do we find each other? How do we find others, people who are part of this group, right? So you can leave a directory where you keep listing all the conversations that are going on. You can send explicit messages. You can send explicit emails so people can join together, right? So the first problem is to figure out how can people join into these systems, right? It's a lot simpler when you have two, like if you have chat with one person. It's a lot harder if you're thinking about a cooperation with a large people, right? So if you want to, let's say, advertise that there's a lecture going on here and invite anybody out in the world to join us, how do we advertise to the rest of the world that there's going to be a conversation here, there's going to be a group here, right? That's part of the problem of rendezvous. And then you have to figure out how to add these users who are part of the system to form this collaborative effort. In terms of once you have these things running, the cooperation component figures out how these entities operate, right? In the centralized model, all the interactions go to a centralized site which figures out what should happen and then sends it off to everybody else, right? So you are talking something, the centralized component which collects everything and figures that you have the flow control, you don't have the flow control, so I get rid of what you said and add these components are sent back. In a distributed model, everybody runs their own stuff, so all the updates go to everybody, and it's up to you to figure out which ones should be should take effect, right? And then the multimedia issues, in terms of what are the different audio streams, what are the different video streams, and how they are part of this system. And you also have to worry about what happens, in terms of network and compression issues and stuff like that, right? So, for example, audio is more important than video for typical video conferences. So, if things go wrong, which ones you drop, those are issues. So, all these three issues form the core of what you would have as a cooperation. So in terms of, if you put all this together into an entity, that entity is called a session, right? So entity is defined as the set of participants and the set of all the media and everything put together into this one thing that we can all operate on. And so if you have this session, then we can join a session. You have notion of a session manager, which essentially controls what the different parameters are. So it controls who will be part of this group. It controls who should get control, who should get the flow control. It should control the different streams. So the session manager is the one which controls all the components which are operating. And there are a number of different protocols on how you put these things together. The first one is the session description protocol, and I think I showed a little bit of how this thing looks like, right? So for people who've done the QuickTime server, right? The QuickTime server lets you create a session description protocol, and essentially tells you where to go for content. What's the multicast address, where the session is going. So essentially, the session description protocol says what is going on. So if you want to, let's say, make the session out of this lecture, session description protocol will say that there's a Multimedia Systems course going on at Notre Dame. If you want to listen to it on Tuesdays and Thursdays from 12:30 to 1:45, join this channel, join this media or something, and then you can and use like MPEG-4 or something, and then you're good to go, right? So that defines what the session is. The session announcement protocol would announce this everywhere, right? So there used to be multicast mbone, which was a research back when people are using for this stuff. So there, whenever you have a lecture or something, you broadcast what you want to everybody else, right? So, for example, here I would say this is a lecture, and I broadcast this to everybody else. And session announcement protocol's job is to make sure on how to transmit it to everybody else, right? So it may be transmitted to everybody inside Notre Dame, it may be transmitted to everybody outside Notre Dame, or what have you, right? It's much more robust than applications like me putting it in my web page and you having to go through and see what it is. It's more similar to what you would look at as a TV guide, right? It's more of a distributed TV guide where I decide what I want to do and I post it, and then it kind of shows up in a TV guide for everybody, right? Does that make sense? It's a lot more powerful than leaving the information all over the place and you having to go and look for them. You kind of aggregate it into this one media, right?
So that's a layer on top of the session and description protocol.
It's all part of the session, the notion of a session, right? The session manager manages each session, and so the session manager, so we have to have a notion of session manager which decides what is happening here. If you take let's take the example of this lecture hall, right? Session manager decides who gets floor control, how we all communicate, all those things. Session description protocol says, how can we describe this to outside world so somebody can join in? And session announcement says how to announce what the description.
Send that description out to others.
Yes. So once you get the session announcement, once you get the session description through the announcement, and you decide to join, then you would join the session. You call the session manager and say, I want to join this session using the protocols that I saw on the session description protocol, which I saw the announcement on the session announcement protocol, right? And actually, so once you do this, you start the session initiation protocol to tell the session manager that I want to start communicating, right? To give you a solid example, if you want to talk to somebody on Skype, right? You can either know what their session description is by having their IDs cached, or you can search for it, right? You can search for the online users or what have you. So through some mechanisms, you can figure out what are the different product people out there, right? And once you figure out who the people are, you can actually initiate a call to them using the session initiation protocol, right? In fact, you use one such thing for voice over IP. So if you're using Vonage or something, that's how you initiate a call with somebody, right? And real-time streaming protocol, I think we've mentioned before, is one of the ways that you actually send the package, whether it's UDP or TCP, right? And there's a protocol to figure out conference. So essentially, together with all this stuff, if you want to have group communication, you have to figure out what happens within a session, in terms of who gets control, how you mix the different streams, how you make the streams fit for different environments, different heterogeneous environments. And then you have to have a way to announce it to others and have a way to join in and have a full setup, right? Does that kind of make sense? So once you do all this, so all of this together define what you would ideally want in a conferencing system, right? Now, many of this can be rudimentary. So the description may just be a word of mouth, and the announcement may just me saying, we have a conference call, please call 1-800, join me or something, and then we can start. But ideally, we would like it to be a little bit more advanced, more of like what you used to in a I guess phone or something, right? Especially when you're trying to do more complicated stuff, you would like it to be much more seamless rather than searching for the stuff, right? So the book didn't go into too much detail about the cooperation mechanisms. We'll try to look at some of the issues of what we'll look at. Hopefully, so that kind of concludes all the textbook contents that we looked at, right? So to recap, essentially we looked at the different ways of encoding and sending those streams, right? But that's only one component of the whole problem. If you want to build a multimedia system, you have to figure out how these different streams are transmitted and how these different streams are sent. But the real fun is in terms of putting them together into, synchronize them across the different streams, being able to build applications where you can define where things should be placed, where things should happen over what. Have creative control over where content should be, right? And where when temporarily when things should happen, and being able to build systems that would tie in all these technologies to make something happen, right? One of the holy grail, for example, on the group communication would be a teleconference where you actually feel like you were there, right? There are some research systems which kind of get you there, and when you get there, when you try to look at these systems, there are a lot of issues which you didn't think are necessary come into play, right? And one of the things that hopefully we'll see on the papers is it's not just okay to be able to communicate with somebody. It's okay you need to have a way of flow control, and that's a lot more complicated than you realize. The subtle social stuff that you want to capture, and unless you do that, anybody who's faced a conference call would tell you that being able to talk to everybody, it's good for the first few minutes, right? But it gets kind of boring unless you have somebody who sits there and says, okay, now you go, right? And many of the conference calls, when I go, it basically somebody would stand up and say, does anyone have anything to say? And that's a bad thing to do, because everybody says yeah, I have, right? And then it's like, huh? And you spend the next 15 minutes trying to figure out who said what, right? Or you have this, I don't know, I think I've been in too many annoying phone calls where you have somebody sequentially going through and saying, okay, so now do you have something to say? And then do you have something to say? And then you wait for 15 minutes because they kind of left the system and you don't know who's still in the system. And you just still hello, are you there? And then somebody joins in and says okay, what are we doing now? And it's we're trying to figure out if anybody has anything to say. And right, yes.
There's another issue about conference calling is you never know who's on. Over the summer, you'll hear beeps and beeps. When somebody going on or somebody get off, you hear a beep.
Mm-hmm.
But then after an hour, half an hour conference call, you don't know who really was on or who really just had left.
Mm-hmm.
It's just kind of one of those things.
You even see it on the news. I was watching the evening news last night, and they were interviewing 4 people about the Supreme Court, and they were like, "Oh, now, John, I'm really interested to hear your idea," and they would stop and let him talk for 2 minutes, and then just kind of hand it off like that. And it was.
But the amazing thing is on the newscast, right? It's not unchoreographed stuff. I mean, there's people behind the camera. I mean, it's not they're impromptu. I mean, they're just they do chat on the thing, but there's somebody who's sitting back and say, okay, now you go, right? And there's somebody saying now you shut up, and somebody has to go and stuff. And even there you see all kind of failures, right?
Well, then you have shows like Crossfire before it was canceled, where you'd have
but those are professionals, right? I mean, they look. No, I'm not talking about
Crossfire.
No, I'm not talking about opinion, right? I'm saying these people know what's going on. I mean, these are not people who are. So if you and I were to do Crossfire on TV, right? We'd probably suck really bad because we won't know the best cue of when you should start and when I should stop.
They just interrupt each other. And they
on purpose, I would guess.
Yeah, but they'd be talking at the same time.
On purpose, I would go.
Oh, I don't know, maybe.
I mean, I'm guessing that they are trying to out-talk each other, right? I mean, I'm just I'm hoping that I'll talk loudly so I will drown you out, right? Right?
Yeah.
So I'm not talking about those. I'm talking about if we all want. So one of the things I would like to do is be able to have a conversation with this class through video from somewhere else, right? And you could see sort of what happens, right? It's a lot easier if I keep talking and I don't have to interact, but if I have to interact, it's a lot harder, right? And hope that we can see the access grid in action, the one in OIT, right? And the assumption here is you have basically wall-to-wall display, so it gives you a sense of you being there. There's also one of the things that I was So some other group which is working on the live meeting or beyond at Microsoft Research, right? It's how do you show who you are, right? So assume that you can one of the problems you said is like after a while in a conference call, you have no idea who's who, right? Let's say you have video going for it, right? So what do you show for different people? Do you show their pictures, or do you want to show avatars of what you want to be and where you want to be? What do you show, right? What would you want to show?
Just the name.
The avatars would be nice because you wouldn't have to get dressed. You could be at home.
Actually, that's an excellent point, right? Like most people don't really want their face the way they look, right? Yeah.
Something that we've usually done with voice chat is have just names show up whenever someone is talking, and then the name disappears when they stop talking. And that way, if someone pops in with an idea, you don't have to figure out who actually said it, because with 12 people and most of them not having known each other for a long time, it's really hard to tell who said what if you don't have video.
I don't think having video solves many of this problem. I think that there's a lot more to human interaction that we evolved over millions of years that are subtle, that need to be captured, right? And those are not that obvious, right? For example, if you're kind of bored, right, you may be like doing like this, right?
That would be kind of annoying if you were watching like 10 people's, heads kind of like move around on the screen. Like you're really annoying if you're trying to watch a conference.
Yeah, and sometimes whatever you're doing has no significance, right? Like if I'm saying something and you're just sitting there and you have nothing to add, right? That doesn't mean that you should, like when you have nothing to add, you like sit still, right? You may be like just sitting there kind of slouching. I don't want like the system to kind of show like, uninterested user, like change colors and show uninterested, right? It's like,
I would love that.
it depends on what you're trying to do, right? If I'm just talking, I don't really want to know precisely what, I don't want you to be acting and like act like, like this, right? You just. Oh, I mean, so one of the other contexts it came about is trying to figure out how to videotape lectures. I mean, like right here, one of the things that we do is like that thing is sitting there dumb, pretty much not doing anything, right? There's a lot of work done at Berkeley and other schools trying to figure out how to capture what happened here in a nice format, right? So one of the ways they figured is it's not enough to just capture me, because capturing me, you like the last bit of conversation we had, you lose the whole thing, right? All you see is me saying whatever, but there's a conversation going on, right? So they're trying to figure out how to figure out what you should do by monitoring people, right? And it turned out to be extremely hard because precisely people don't actually express stuff in an easy fashion for me to recognize, right? I can recognize as a human being, but not as a system, right? So when you kind of don't understand something, you don't actually have like your face, there's a big question mark show up on top of you to show what's going on, right? But as a human being, I can see like little subtle clues to see whether you're kind of lost, right? And you're answering to those. So one of the things you notice is if I say something, right, and I look at somebody asks some question and I look at them, you kind of see how much they know. I mean, what the feedback you get, and then you talk more or less, right? So if somebody says something and I say one word and they go, oh yeah, kind of stuff, right? I don't continue on with the stuff, right? But capturing that, what happened there for posterity is very hard, right? Because if you don't have the context, you don't understand what happened, right? And anyway, so hopefully you have an idea of what are the basics of what these systems can do, and after the midterm, we can go on to look at more more interesting systems, right? So this is a good time as any for you to get back to me on whether you want to look at any particular system, either in the research context or more of a lecture kind of context, right? Especially like, only thing I remember from you is the more encoding kind of stuff, right? But is there anything you'd like to look over? We can look at it afterwards. Do you have any other questions before we leave? If not, we'll see on